Okay, class, good morning, and this is our discussion on the assignment for Module 1. So basically, this is your first assignment for Module 1, and you can see that I have given you three problems. Number 1 is you borrowed an amount of 20,000 from your classmate at January 31. You promised to pay the amount with interest in full in March 31, 2020. So, interest rate is at 12% per annum. Compute for the amount due to be paid based on the following. Number 1, simple interest. And number 2 is the simple exact interest. So, this is our solution computation. So, as you can see, the borrowed amount, the given is on the upper left corner of the second page. And then, you can see that the borrowed amount at January 31 was 20,000. Interest rate is at 12% per annum. And payment due will be on March 31. So, formula first for simple interest is that the future amount is equal to the present amount 1 plus RT. R is the interest rate and T is the time or the amount of time the money was borrowed. So, let's solve first using the simple interest. So, as you can see that the on simple interest, the payment due would be on March 31 and then the amount was borrowed on January 31. So, basically that would be exactly 2 months from the time the money was borrowed. So, given that your interest rate is per annum, meaning for per annum, that is annual rate. So, let's try first to solve for the value of the interest rate. So, per month. So, given that you have 12% divided by 12 months, that would mean that, I'll erase this one, and months, that would mean that the interest rate every month is at 1%. Okay, now we know that the interest rate is at 1% per month. So, given that you already know that the interest rate per month is 1, so basically you can already compute for the future amount using the simple interest. So, the present amount or the amount of money borrowed is 20,000 multiplied by 1 plus the interest rate of 1% times 2 months, close parenthesis. So, F is equal to, okay, kindly get your calculator. So, 1.01 times 2 plus 1, that is 20,000 times 1.02, which is equivalent to 20,400. So, for a simple interest, you have to pay the amount of 20,400 on March 31. Now, let's go through the simple exact interest. So, as you can see also, we'll proceed with our simple exact interest. The n or the number of days is crucial in computing for the value of the simple interest. So, provided that the amount was borrowed on 2020 or year 2020, since it is a leap year, we have exactly 366 days for that year. So, 12% per annum divided by 366 days, that is equivalent to 0.12 divided by 366. That would be 3.27 times 10 to the power of negative 4. So, that would be your interest times 100%. Your interest rate would be equivalent to 0.03% per day. Per day. Na. So, given that your R is equal to 0.03%, I'll erase the rest of the computations. Okay, so your future amount, let's compute already for the future. Future amount is equivalent to 20,000 times 1 plus 0.03% multiplied by the number of days. So, let's try to check first how many days is from January 31 to March 31. So, basically, February is 29 and March is 31. That is equivalent to 60. So, that would be your multiplier for this part, meaning that would be equivalent to F is equal to 20,000 times 60. 1.019672131. So the future amount would be times 20,000, that is equal to 20,393.44. Okay, we're done with our assignment number 1. For assignment number 2, if you have invested 2,000 now and invested it at an 7% interest rate per annum, how much would it be at the end of 8 years? So, 8 years. So, find the value of money at the end of every year using simple interest, compound interest, and draw a graph on the two computations. So, for assignment number 2, you are given the following. So, investment now is $2,000. Interest rate is 7% per annum. So, let's try first to compute the value of the interest for the first year. So, for a simple interest, F is equal to 1 P1 plus RT. So, F on the end of first year is equivalent to 20,000. Or wrong. That is 2,000 times 1 plus R is 7%. T is 1 at the end of first year. So, basically, your F1 is equal to 2,140. Okay. And then, let's jump up to the value of the investment in 8 years. So, F at the end of 8 years is equal to 2,001 plus 7% multiplied by 8. So, the future amount or the amount of the investment in the end of 8 years would be equivalent to 2,000 multiplied by 1.56. So, that would mean that the value of your 2,000 investment at the end of 8 years is 3,120. Also, the graph for the year by year solution for this one will be posted on our Canvas class. So, okay, so now you can see the solution for the simple interest. And then for compounding interest, as we all know that the formula for compounding interest is that F is equal to P 1 plus I to the power of N. N is the number of years, or you can denote it as T also. So, So let's compute first the value of your investment at the end of the first year. So F1 is equal to 2,000 multiplied by 1.07 to the power of 1. 1.07 because the I is 7% plus 1, that is 1.07. So the value of your investment at the end of the first year is equal to 2,140, which is basically the same for the simple interest. That is because the value with interest at the first period of a compounding interest is equivalent to the simple interest. But let's try to check the value of your investment at the end of 8 years. So F8 is equal to P 1 plus I to the power of N, wherein your F is equal to 2,000 multiplied by 1.07 to the power of 8. So with that, it would give you a value of 3,436.37, which is, it would give you a difference of $316. So meaning, basically, on a compounding interest, the interest earned on the previous years or the previous payments or value would also gain interest when it is compounded. Unlike the simple interest, you only gain interest based on the investment value. Okay? So with that, you can see through the discussion point on the PowerPoint discussion for this assignment, and you can see the graphical representation of each of the computation. So let's proceed to our assignment number 3. So for assignment number 3, suppose you are offered the alternative of receiving either 2,007 at the end of 5 years or 1,500 today. So there is no question that the 2007 amount will be paid in full. Assuming the money is not needed in the next 5 years. So assuming you don't need it right now, you deposited the 1,500 on an account with that pays an interest rate which you do not know. So what value of interest would make you choose to deposit the 1,500 today? So next is, what is the value of your investment at the end of every year, year 1 to 5? What would be your initial investment if interest rates are 3% and 9%? Consider that it is a compounding interest. So as we all know that provided that this is a compounding interest, formula would be is that F is equal to P 1 plus I to the power of N. Okay. Future amount is 2,007. Present amount is 1,500. So basically, 1 plus I to the power of N. N is 5 years. So substituting the values, that is 2,000 equals to 1,500. 1 plus I to the power of 5. So dividing that one, that would be 2,000 divided by 1,500 equals to 1 plus I to the power of 5. Okay? And then, in order to get the value of interest or the interest rate, you have to, I'll transpose everything ha. So, that is 1 plus I, fifth root of 2,000 over 1,500. Okay. I'll transpose the 1 over here minus 1. So your I is equal to 2,000 divided by 1,500. So that would be 5.922%. So the interest rate earned on the first example is at 5.922%. So that would be equivalent to 6% per annum. Next, what should be your initial investment if still you need to earn the 2007 at the end of 5 years? And what is the initial investment if your interest rate earning is at 3% and at 9%? So let's start first with the 3%. So assuming that you have the same future amount value, P 1 plus I to the power of n, and then the value you do not know yet as of the moment is the present value or your investment. Okay. Let's try transposing everything. So F over 1 plus I to the power of n is equal to P. Basically, by rule of math, it is equal. So P is equal to F, the future amount is 2007 divided by 1.03. That is at 3% per annum. And I'm wrong again. Okay. This is 5. So, if you are earning in an interest rate of 3% per annum, basically the value of your investment should be, get your calculators, should be 1,731.26. You need this amount in order for you to get the same future value of 2007 at the end of 5 years. Next, let's try computing the 9%. So let's write down the 6%. Let's write down here the summary at 6%, 1.5 at 3%, pila to? 1,731. So now, let's try computing it at a 9% interest rate. So, at 9% interest rate, same formula. P, 1 plus I to the power of n, where P is equal to F over 1 plus I to the power of n. P is equal to 2007, that is your future amount expected, 1.09 to the power of 5. That's a divisor. So, the investment needed for you at a 9% interest rate would be 1,304.41. So, at 9%, that would be 1,304. Okay. So as you can see, the higher your interest rate, the lower the value of your investment, and then the lower the interest rate earned, that would need a higher investment for it to provide or give you a same amount of value at the end of 5 years. So summary wise, you can see that one. And then for the value of the investment from year 1 to 5, it will be given through a PowerPoint discussion. But for this one is the manual computation on how to solve your assignment. So this is all for now. So bye bye.